In this lesson, we are going to learn conditions that imply congruent triangles. Congruent, as a reminder, means that you have the same size, same shape. Okay, so let's look at these two triangles, same shape. We're trying to figure out, are they the same size as well? So these, what we have to look at is your hash marks. So this is a 1 hash mark, and this one is a 1 hash mark. So this side right here is congruent to this side right here. So AF is congruent to MZ. And I'll look at this right here. This is a double hash mark. So segment DF and segment MQ are congruent. Now if I look at the third side, AD, right, these have 3 hash marks and these have 3 hash marks. So segment AD is congruent to segment QZ. So all 3 sides are congruent, so these two triangles are congruent by side, and side rule. Okay, it's actually a postulate. So let's see, how do we name it? Well, this says we go from A to D to F. So A is the long side, D, and then this is the shorter side. So I will go from the longer side, so Z, Q, M. Okay, so I will call this ZQM. Triangle ZQM. All right. Now let's go over here. This time, let's see, we have side angle side, right? So this is side angle side. Okay. Notice that the angle is in between the two sides. This is called an included angle. Okay. So let's look at our two triangles. We notice the hash mark right here. So this segment BM and this segment SL both have 1 hash mark. So those corresponding sides are congruent. And I'm going to go to the other side right here, MK, these have 2 hash marks. And I go to LG, they also have 2 hash marks. So these 2 sides are congruent. And then I go over here, well, actually, I have an angle right in the middle of these 2 sides. So angle M must be congruent to angle L. So the side angle side rule applies here. And so these 2 triangles must be congruent. So let's go look at our naming. This says triangle BMK. B is up here, K is there. So BM is the longer side. So this will then be SL to G. So this is going to be my triangle SLG. Okay, so these 2 triangles are congruent. Now let's go for ASA, and this stands for angle side angle. Okay, notice again, this time it's the side that's between the 2 angles. So this is an included side. So let's go look at this. Let's see, I have a side XC, and it is congruent to side RB. Again, it's because this has 1 hash mark, this has 1 hash mark right there. Okay, now let's look at the angles. I have angle X right here has 1 line, and angle R also has 1 arc actually. So X and R, angle X and angle R are congruent. Then I'll go over here to my other angle. Angle C has 2 arcs right here, and this is another arc right here. So angle C and angle B are congruent. So let's say they are congruent. And let me trace out how did they name this. So it's triangle XCP. So XCP. So they started with this angle right there, the one arc. So I'm going to say, I want to start also at R, B, and then N, right? So that's my direction. So I will say it's triangle R, B, N. Okay, so now we go to angle, angle, side. So angle, side, right? So angle, side. Two angles are together and side is not in between, okay? So let's look at our lines. I have, this is my side right here, this side and this side. So ZE is congruent to HU, segments HU. So I know these sides are congruent. Now if I look at my angles, angle A and angle O are corresponding angles that are congruent. And then angle Z and angle H are corresponding angles that are congruent. So this is an angle. So again, angle, that's your angle here, that's your angle here, and that's your side. Okay, so this is the angle side rule that shows that these two triangles are congruent. So let me take this out because I will trace now. It says triangle AEZ, so it goes from the angle A to E, and then it goes up to Z. So we will try to follow the same path. So it goes from single arc to H, right? So this is going to be triangle O U H. Okay. All right. Next rule, HL stands for H stands for hypotenuse. All right. This is the longest. That's the longest side of a right triangle, right? You need a right triangle for this, okay? The L stands for leg, okay? So there are two legs in a right triangle. So let's see. How do I know it's a right triangle? Well, there is a little box there that says it's 90 degrees. So this is a right triangle. Both of these are right triangles, and the hypotenuse is across from the, or opposite to the 90-degree angle. From middle school, you guys know this as C, right? You guys call that C in middle school. But now we are calling this a hypotenuse, right? This is our hypotenuse, okay? And it says here that our hypotenuses are congruent. So VY has 2 hash marks and WS has 2 hash marks. So these corresponding sides are congruent. Now all we need is a leg, and notice that KY here has 1 hash mark and RS has 1 hash mark. So these sides must be congruent. And again, this is a leg. This is also another leg right here. VK is also another leg. But we only know that KY is congruent to its corresponding side RS. Those legs are congruent. Okay. So again, this is a leg. This is also your hypotenuse, right? Both of these are hypotenuses. Okay, that is hypotenuse. So this means that both of these right triangles are congruent because the hypotenuse and a corresponding legs are congruent. So let's name this. It says KVY. So K and then V, then Y. So let's see, my K is here. Let me change my color. K to V, so it's short leg first, and then Y, right? So I'm gonna go up my short leg, and then I'm going to go to my S. So when I'm naming this, I'm going to say it's triangle RWS. Okay? So these are two conditions that show that the triangles are not congruent triangles, right? So both triangles, same shape, but not the same size. So AAA stands for angle, angle, and angle. Okay, so angle, angle, angle. So you have this angle here. These angles are congruent. These are corresponding angles. This angle right there that has two arcs, and then, well, this has three. 1, 2, 3. So these are corresponding arcs. These corresponding arcs, or sorry, angles, are congruent, but it doesn't mean that they're the same or same size triangles. Obviously, one is larger. Later on, you'll learn that these are proportional. If you have angle, 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 angles being corresponding angles are congruent. But again, they do not guarantee that the two triangles are congruent. ASS stands for side-side angle. Side-side angle. Okay. So this is one angle right here. So these angles are congruent. And then we have this side right here. AB and, well, A prime, B prime. So these two sides are congruent. And of course, you have your AC right here, and you have your AC. This does not guarantee that the triangles are congruent, just because this side right here, let's say A prime, C prime, could actually be something like this, where it's this AC is still congruent to AC prime, but it doesn't form a triangle. So that's why we can't guarantee that these two triangles are congruent using the side-side angle. And we like to say, if it spells SSA or ASS, no donkeys, right? That is not a congruence rule. All right, so let's look at these examples here on the bottom. So finish the congruent statement between the triangles and state the postulate implied. If the triangles are not congruent, write no conclusion can be made. So let's look at number one. Let's see. This says that one hash mark here. So HO and SE are corresponding sides that are congruent. It also says that my angle here and my angle here, angle H and angle E, are congruent. So I have an S and I have an A. Now, what else can we tell that is congruent? So if you guys remember, if you look for X's, right? This is an X right here. These right here are opposite angles. They're known as vertical angles, and vertical angles are always congruent. So these are your angles right here. So we know that by AAS or SAA, our triangle HOU, let's go see, HOU is here. Get the highlighter. So HOU flows this way. Okay, so I will see. It has one arc right there. That's another arc. So I will say it's ESU. Okay, so this is my triangle ESU, and I forgot my triangle. So let's move this over here. my triangle symbol. Okay. So triangle HOU is congruent to triangle ESU by AAS, angle sides. Okay. So let's go here. This is a triangle symbol again. So let's look at our two triangles. So we have two triangles here. Let me split it up. First triangle here is FGJ. Well, yeah, FGJ. That is one triangle. And notice that other triangle here, triangle GHJ, is a reflection actually of FGJ along GJ. So I can actually rewrite this. Let's rewrite this as this right here. And I'm going to say this is my H. This is my J still, and this is my G. Okay, so I'm trying to match this. Is there a way to rotate this? No, I cannot rotate it. But, so let's go through this. I know that FG and HG, these are congruent right here. FG, HG, and then I have FJ. So I have FJ is here, and that's the same as HJ. And then, well, both of these actually share the same GJ, G to J, G to J. So what's happening here is that I have a side. Three corresponding sides are congruent. So I know that by SSS, side, that my triangle FGJ, again, let's see, let's use this, FGJ goes from here to here. So I will do the same thing. It goes through there. And so this is going to be triangle HGJ. All right, so let's look at this next one. Number 3, what additional congruence must be established to prove triangle RAD is congruent to triangle BUL by ASA, angle side angle. S is in between the two angles, right? So S is the included angle. Again, that's vocabulary. Included, oh, sorry, side, included side. Okay. So it's in between two angles. So if I look at this triangle right here, see, I know that RD and BL are congruent because of this one hash mark right there. So I've got an S. Okay, so I've got an S. I've also got an angle right here, an angle right here. So angle D and angle L are congruent. So now I have an angle. Now I need ASA. So I've only got an A and I've got an S. So I need an A. So remember, the side right here is in between two angles. So my side has to be in between this angle right here. That's got to be my angle. So let me change the color. I will use brown right here. So my R, angle R, and angle B. All right, let me double it. Angle B. Those must be shown to be congruent. Those two corresponding angles should be shown to be congruent so that you can say that the two triangles are congruent by ASA. So, for addition to this, I need to say that angle R must be congruent to angle B. All right. Okay, next we have number 4 in the diagram. BD bisects. So this is our BD right here. So it bisects triangle or angle ABC. So let's see, let's highlight ABC. ABC is here. So that means these two angles must be the same. Okay, so ABD or angle ABD must be congruent to angle DBC. That's by definition of a angle bisector. What additional congruence must be established to prove that the two triangles, triangle ADB and triangle CDB, are congruent by SAS? Again, notice that A is in the middle, right? That's in the middle. So I need, and I've got one angle right here, right? So this is my A, okay? Maybe I should, let's do this. Let's draw another triangle. So let's flip this triangle right here. Let me highlight this. So BDC right here, I'm going to flip it right here. So now this is my C, this is still my B, and this is my D, right? So I've reflected it. And now I know that my two angles up here, ABD and CBD, are congruent. I also see that, well, they're sharing the same side, BD. So I know that BD, let's do this, let's do BD. This whole line right here is the same, congruent with BD, right? So BD is congruent to BD. And then, what do I have? So that's a side. So it says here again, A has to be in between two sides. The angle has to be in between two sides. Well, then it means that I need to know that this side AB should be congruent to CD. That way I get side angle side, so SAS, right? So again, AB must be congruent to CB.